On April 20th, 2019, high school and middle school students from the University of Utah CSME Refuges program launched a scientific payload via high-altitude balloon with Dr. Sten Hasselquist from the University of Utah. The goal was to answer a science question the students themselves had developed earlier in the school year. How does the temperature and pressure of the atmosphere change with altitude? The payload, which the students assembled, consisted of a GPS tracker to find the balloon, a camera to record the launch, and a computer that took temperature, pressure, and altitude measurements every 6 seconds. We launched from the Knowles OHV area west of Salt Lake City. The balloon traveled 40 miles northeast during its 2-hour flight time and ascended to a maximum height of 82,000 feet. High-altitude balloon launches are not easy, and everyone had to execute their jobs properly for the launch to be a success. The first step was to fill a balloon up with helium. This process took about 30 minutes, and we put 90 cubic feet of helium into our 350-gram balloon. While the balloon is tame in the early stages of the filling, as more helium enters the balloon, the buoyancy force becomes larger, and our balloon wants to take off. Therefore, it is essential that we all work together to make sure our balloon does not leave without our payload. We also have to be careful not to pop the balloon while filling. The students assisting in the filling process easily overcame these obstacles. During the filling process, it was the job of some of the students to power on our payload systems and verify our instruments were working properly. We also made sure to contact the FAA at this time to let them know that we are about to launch our balloon so they could reroute aircraft if necessary. After tying up the balloon and attaching the payload, we went through our launch checklist one more time and declared ourselves ready to launch. In these launch videos, you can see that we have our balloon, followed by our red parachute, followed by our triangular science payload. Here's another angle of the launch. And here is what the launch looked like from the camera on board our payload. Our payload does spin on takeoff, so if you do get dizzy, look away for a few seconds. The balloon took about 1 hour and 15 minutes to ascend to 82,000 feet, where the balloon then burst and returned our payload to the ground. Most of the curvature you are seeing at the horizon of these videos is not the actual curvature of the Earth, but an effect of the fisheye camera lens. Had our camera survived to 82,000 feet, we would have been able to see the curvature of the Earth, but unfortunately the camera only lasted for 45 minutes. These last seconds of video you're seeing here were taken right before the camera died, which was about at 42,000 feet, higher than you would fly in a commercial airplane. We later found out that the temperature at this point of the flight was minus 35 degrees Fahrenheit. Our temperature measurements show that at 35,000 feet, the temperature profile changes from smoothly decreasing with altitude to being constant with altitude. The boundary at which this change happens is referred to as the tropopause and separates the troposphere from the stratosphere. We also found that the pressure of the atmosphere decreases exponentially with altitude, and at 82,000 feet, the pressure of the atmosphere is 2% the pressure of the atmosphere at sea level.